I'm Lata Chaudhary, and I started with AT&T,
Okay.
doing big data and SAS and
Okay.
all those R, C++, which are precursor of SAS, of our language, the C++,
Okay.
with Bell Labs. And I was there 21 years.
Okay.
And most recently at Verizon.
Okay.
And we did a lot of this data mining, data exploratory analysis, and algorithm development.
Where did you work in AT&T? Like which office?
Basking Ridge, Bedminster, Bridgewater, all around that area.
I started with AT&T.
Oh,
My
really?
first job was in AT&T, Somerset.
Oh, really?
Yeah.
How long you stayed?
I was there for 1 year and 2 months. Then I got outsourced to CSC
Oh, CSG, yeah.
and stayed there ever since.
So AT&T one, that's good.
Yeah.
So we all come from that AT&T world, right?
Right.
Yeah, my recent job with Verizon that got outsourced to our Infosys. So I was teaching and maybe you get a
just
copy.
keep this copy
Yeah.
if anyone comes in.
Okay.
I did their initial training right out of college.
Yeah.
With C and Unix, Awk, and all the scripting languages.
Yeah.
And after that, started working in ISNS. You might have heard of it.
Yeah.
Integrated Sales and Service.
Yeah.
Okay. Was for customer service. The integrated system at that time.
Oh, yeah. I've been doing a lot of
before-
customer service with Medicare right now.
Okay.
So they want to put in chat, machine learning, to improve the process. So,
Right.
and that's a good, way to give back to the community because my demographic is 65 and older,
Okay.
and they need the most care. That's the
Right.
biggest growing population in United States. So.
Right. Yeah.
So AT&T, then CSG, right?
CSC.
CSG.
Computer Sciences Corporation.
Oh yeah, that's Ross Perot's.
No.
Ross Perot, no.
No, it's Mike Lowry is the CEO right now.
Oh, okay.
And we changed our name. We merged with.
So you have been here for long, 20 years now.
20 years with the company. Yes.
Oh, but you can work from home.
Yeah.
So where in Pennsylvania you are?
In Chalfont.
Near.
Do you know where Peddler's Village is?
Yeah, that's a beautiful area. Yeah.
Maybe about 10 miles from there.
Yeah, I live on that or 202. Around 202.
This is on 202. Chalfont is on 202.
Oh, really?
You know Doylestown? Next city.
Okay, I'm in Bridgewater, but in the Brandsburg, Bridgewater area.
Right.
So.
We used to live over there near Belmead.
Yeah.
We used to live there before.
Yeah.
And then moved to Pennsylvania.
That's a nice area, yeah.
Yeah, it's a lovely area.
Yeah.
Very expensive though.
Excellent.
The taxes are actually.
More than Bridgewater? About?
Probably is. Like the house that we had at the tax back in 2002 of about 20,000. That was pretty much.
Yeah. Oh, wow, yeah. It's like all those start hills and everything, right? Are we starting or nobody came in yet, I guess? There's 2 more.
No one else has joined.
Yeah, no one else is there. But I just want the recording, so if someone wants to see the recording and come to the class, for
Okay,
them,
you can distribute it later.
Yeah.
You can do that? Yeah, they didn't tell me they're going to audio record this.
Oh, okay.
Yeah.
Is there any sensitive material? I mean, other than that, there's not really, because this is not going to be on like a YouTube or anything.
Okay.
It's just going to be like for people who wants to join the class.
Okay, all right.
If they want to see a demo.
Yeah, don't put it like,
Oh, no, it's
yeah.
not going to be.
Because I was going to talk about university and I'm a state employee because I'm an adjunct professor. Something might be proprietary. I won't show this
it's
one.
not going to be.
I can talk about it. Okay.
Yeah.
Yeah, this one I'll talk about it.
Okay.
If you want to share, we'll share later.
Okay.
Whoever wants it, right?
Okay.
Okay. So what is data science? It's actually basically statistics with the computing ability with big data. So I am a data scientist, which is a blend of statistical computing, statistical reasoning, because they always want to know why this versus that,
Right.
Customers got converted and no or yes. And also business domain, because I'd worked in retail, pharmaceutical, and mostly telecom.
Okay.
And so if I can help you with those, that would be useful. And I worked with big data analytics at KPMG, AT&T, 2.5 billion transactions.
Okay.
So when they load it up, we had groups like Hadoop people that summarize the data so we have manageable data sets.
Right.
But it's something that Excel cannot handle. So I'm going to demo some SAS and probably R.
Okay.
And so that was a book on R, which is an academic book for a master's MBA program, but you can just write it down.
I did.
And whenever any student want it, I'll ask them if I can share the book. I have some ebooks.
Okay.
Then you don't have to buy it.
Okay.
Okay. So this is a century of data, and data science became prominent after 2011 when I joined retail group at Bed Bath and Beyond. I set up the whole e-commerce strategy,
Okay.
and looking at campaign like sales before and after. So this is all transactional data, very big. Audio restored. Why does it say that? Okay. And so I developed the KPI. So everything is summarizing data.
Okay.
So sometime in big data we need probably SQL to get data from the database. And for doing the predictive algorithm we need R,
Okay.
Python. I'll touch little,
Okay.
and SAS.
Okay.
And then help you understand those, and your choice whether you want to use the GUI or the other. But what I'm finding, I know the two, at least R and SAS very well at Verizon. SAS is proprietary, so it's not open source.
Right.
So the algorithms are proprietary of the company, which is good. But in open source, anybody can share,
Right.
so they can take your trade knowledge. So like Goldman Sachs and all those regulated industries like telecom,
Right.
pharmaceuticals, and they cannot use the open source.
Okay. So they don't use
they use
Python
SAS.
or R, they use
No.
SAS. Okay.
But SAS has a connection add-on to Python and R,
Okay.
which is also proprietary to buy through SAS.
Okay.
So I had worked in regulated industry, right? FDA approved, so SAS was used.
Right.
Verizon SAS was used. Even now with Medicare, especially with federal government data, SAS is very big. Originally they said Python, but I said Pythons are for younger people because they don't have the domain knowledge. They want to get into it and the computer science majors, and they want to work for startups or smaller companies.
Right.
But when you want to get contract or jobs with bigger establishments in New Jersey, New York, SAS is the way to go. Even like advertising in Amazon, Facebook, marketing office, they use SAS.
Okay.
Not for the development. They have other software engineers doing that,
Right.
So this is data science would be for feature engineering and algorithm development in this class.
Okay.
Not to do other things that we do. Feature meaning variables,
Okay.
like what variable is predictive of this person, how we can pattern recognize,
Okay.
So I'll cover structured, unstructured data, which is structured meaning all the numbers,
Like
So
the
that
database,
capstone project will be a number, and we'll do like different, projects.
Okay.
Then text analytics is unstructured, and like banking, if you go to banking, they use those copy of the what do you call checks. That's image processing.
Okay.
So I'll just touch base on that, like Google TensorFlow,
Okay.
some other tools,
Okay.
and then you can self-learn.
Okay.
I mean, because this is not like a coding class. You know what I mean? I'm giving a general overview, but
Okay.
I'll do the coding in SAS and R and Python and show you.
Okay.
And just to be a domain expert, I gave presentation at William Patterson. I don't know if this will come out. You can look at it when I send out the view graph. I have to just put some proprietary thing on my name before I send it out. And then most recently, I was invited by IIT Guwahati
Okay.
and Don Bosco University in Assam to give a workshop on machine learning.
Okay.
Because a lot of the students, they want to come to US, they don't know much about,
Right.
And I, as an academic person from William Patterson, I was on the research gate. That's why they found me.
Okay.
So the government of India sponsored that. You can look at it, these two, when I give you the thing. So the base thing is like as you work for AT&T, it's still recording, right?
Yes.
Okay. How do I minimize, shrink it? Okay. Is to whatever you do numbers, people, ultimately the American managers, all the big bosses everywhere, they just want to know the big picture of it. They don't want the nitty gritty detail. So whatever we learn, we have to transform into a layman's term.
Exactly.
So they understand. So what is three big data? It's about volume, velocity, and variety.
Okay.
Yeah. If they can print, I can print it, but I have to put a proprietary like my pro, because I'm using that for university teaching.
Right.
So it's not their proprietary, So
Okay.
like I have to put a note or something there. So big transaction like the credit card transaction, interactions, observations. It could be CRM, which is the customer relationship manager. For example, at Verizon, I developed a revenue churn model, and that led to algorithm in logistic regression,
Okay.
and it was uploaded in CRM.
Okay.
So after that, there's the interface between human and machine. Computer processes the big data,
Okay.
and every month they get their,
Reports.
and they were able to cross-sell and upsell.
Okay.
So today's economy, it's very digitized. So everything is in the algorithm economy. People have no time. They go so quick, and then we have to keep the existing customers happy. We don't want them to leave Verizon. Same thing in Medicare. You don't want to leave them, They'll go to United Healthcare, Blue Cross Blue Shield doesn't.
Great.
So it's very important to keep the existing customer and cross-sell and upsell. And finding new paths. That's the big strategy. So customer experience is getting very important right now. So all kind of data makes it here. So these are the megabyte, terabyte, petabytes of data. And this is big data. And I'll be using big data comprised into smaller data set to give you examples from kaggle.com. I'll talk about it. Google has a data set thing where it's all summarized into smaller data set you can download as CSV and then do the programming. So you had done some programming, right? In SQL and
basically use ASP and SQL Server. A lot of JavaScript.
SQL Server or the Teradata server? No.
SQL Server.
Okay. So you use MySQL?
No, Microsoft SQL Server.
Yeah, that's what we are using at Horizon Blue Cross Blue Shield, I think. It's in what is called that database, Access database from my company right now. But in Verizon, we have to do big data. So sometime it might be, so it's good to know about it, right? So machines learn by studying data to detect. Can you see it properly? Make it bigger.
Good.
So machine is the computer, right? And then we are the human. Categorize data like people or things, predict likely outcome. For example, I did an example of Titanic. Like here we can do an example of in a school shooting. How can you predict it by behavior of people, geography, to avert adverse. I don't know if I'm teaching at very high level. Let me know.
Okay.
Because I come from the company and academia,
Right.
So if you don't understand, just stop me or we can do Q&A.
No, it's fine.
Yeah. So identify those unknown pattern is so important. So data science right now and machine learning is used for recommending product like Amazon selling something, eBay, but we can use better for humanity. For example, predict the tumor, predict the unusual situation of a school shooting, like all the synagogue searches are being targeted. If we know the behavior of the people that go attend, their demographic, something could be averted with machine learning in future. I don't know.
Right.
That will be for policy and with the police.
Right.
Yeah. So it can be used in many different ways, right? So process that the machines learn are called algorithms.
Okay.
In statistics, we call it equations, So different algorithms weigh in different ways. As data rigor, observed responses or changes to the environment are provided to the machine, the algorithm performance improved. Therefore, resulting in increasing intelligence over time. For example, a churn model, I had 7 predictors, whether they're going to leave Verizon or not based on IPCOM revenue.
Okay.
And then we put it in the CRM system. Every month when the new data comes in, the machine splits it and says these are the customer likely to leave.
Okay.
So salespeople look at it and go and try to cross-sell or upsell and keep them from leaving.
Okay.
Because it's very costly when they leave, you lose the contract, lose everything.
Right.
So that's how, machine learn.
Okay.
So thank you. So common applications are proactive maintenance, fraud detection, self-driving car like Tesla, resource optimization, virtual assistant, anything you can think of, predicting infection in terms of medicine. The 4 types of machine learning are supervised, semi-supervised, unsupervised, and reinforcement. So unsupervised are a clustering. There's no target variable. We're not going to predict anything, but you want to know the pattern of people that visit like Facebook page or something, So they're called clusters. You put similar people in different clusters.
Okay.
This is very important for anomaly detection, especially in cybersecurity.
Okay.
Right now, cybersecurity is more than $20 billion business, fraud.
Right.
So if somebody looks different from the rest of the population, that could be a fraudster.
Okay.
So like each homogeneous group
Mm-hmm.
will have a mean and a distance,
Okay.
between the people.
Okay.
So it looks like simple statistics, which is mean variance.
Mm-hmm.
But if it's a 3 times variance, that means it's likely to be a fraudster.
Okay.
And so unsupervised is very useful
Okay.
in a population study, like you are looking at different population of US.
Okay.
So you can put into homogeneous group geography, psychographic, firmographics, or demographics.
Okay.
And then and every data will have lots of variables, like 2000. So we use the technique, principal component analysis, to reduce the number of variables and find the most important variable.
Okay.
So these are all exploratory data analysis. And supervised would be like regression, neural network, Mars, card classification regression tree. So we still need human thought later. It doesn't mean that machine in practice require human application. They do. So it's not like your job will go down. If you develop the algorithm and put new variables, you still need a human interface.
Right.
And then machine will pick up and do the thing, So a lot of customer service job may be gone, but the people who develop this or know the knowledge of algorithm will always be there, needed.
Okay.
So it is a niche market that way. And there's a lot of scarcity of resource right now, because last 20 years most Americans didn't study like math, statistics and computing. So it's and jobs cannot go outside now.
Right.
So whoever you have, there's still demand.
Good with them. Yeah.
And we should still keep on working, right? Yeah. So as you can, why are we trying to predict what's a correlation? Causal is an important thing. Like you do a regression and you found this is causing this, like, why a customer leaving? Because there are too many trouble tickets in the week. But there could be other factor that you cannot control.
Right.
So sometimes looking at text analytics, testimonial help, those are the cause.
Right.
Then we do Pareto analysis where we find the most important cause why customer are leaving.
Okay.
Then second, so the magnitude goes down.
So how do you get the data? From the CRM system?
Yes, CRM.
Okay.
And then it could be a simple plot also. Sometimes you need simple,
let's say
bar plot.
You're doing analysis on why people are leaving. So you get the data from CRM, they have a checkbox or something, or you do data reads or like text reads, or how do you figure that out?
Yeah, it could be text read also. That's what I'll be doing. I can tell you more when I get in there. And parsing, looking at similar words, why they're dissatisfied, this, that.
Right.
Not happy.
Okay.
So all are framed together and then categorize them.
Right.
And once you categorize, then you can do the frequency count. And the highest frequency is the most problematic area. For example, in Medicare, it was like something to do with the resolution of the billing. So they don't like it. The bill keeps on coming and they will leave,
Right.
to go to United Healthcare, Anthem or something.
Mm-hmm.
So to prevent that data has to be transferred into customer service, tell them why billing is the problem. So billing is the biggest problem.
Okay.
Everywhere. In telecom, I'm saying that in healthcare. So you categorize, then you tell them. So for big managers, that's the most important chart, the bar chart, which you call it Pareto.
Okay.
So it goes from bigger magnitude to smaller. So this is the most problematic area. Take ownership, correct your billing, so the customers will stay.
Okay.
Yeah. Can this and the proper response, those can. So 7 habits of highly effective data scientist statisticians. The word statistician came in 2011 when Obama was president, and the chief data officer for him was Sam Patel. He coined the word data science.
Okay.
Actually, it is statistics originally. So defining the objective. Suppose they want to reduce customer churn. That is the company's objective. Then you gather the data based on your meetings with the people, high up, and see what data to gather, because there will be a lot of tables in the MySQL or
Right.
so you do a knowledge discovery in database, see what data looks good,
Okay.
what could be correlated, then you cannot use it.
Mhm.
And then preparing the data for modeling by
Okay.
looking at missing value,
Okay.
and then you have to input missing value using different techniques. Generally, mean or median comes up that 20% of population lessens that. So that's an important thing. Then selecting the variables could be by looking at principal components, so which variables are important,
Okay.
and
Okay.
correlating. I'll go through all this.
Okay.
Validating the model, and then implementing and maintaining the model. Here we cannot implement, we don't have the system, but there is a thing called PMML, predictive model something, markup language,
Okay.
that helps upload it from the desktop or wherever to the actual CRM.
Okay.
I'll talk about it, what it means and all that,
Okay.
but I don't think we can do it, in production here.
Okay.
They only give laptop and there is no other thing. So machine learning is a synergistic exercise between man and machine. Machine learning in practice requires human application of the scientific method and human communication skills. Successful organizations have the analytic infrastructure, expertise, and close collaboration between analytics and business subject matter experts. So becoming a subject matter expert would be very important. Like whatever you do, if you're looking at system performance, you can still apply statistics,
Right.
So knowing that extra number crunching, number of data acumenship helps.
Right.
Helps get your raise or a promotion or look for, So we are all skilled people. We want to improve our skills, right?
Right.
And then the hot topic now is called deep learning, which is more technical, computer scientist, but it also uses statistical algorithms. These are like neural networks, how the human brain thinks, and it's like the artificial intelligence,
Right.
They are called deep learning because the models are significantly more complex or deep than traditional neural network. Deep learning models are ingest vastly larger amount of data than the predecessors. So why it's important? Deep learning is undermining of many advanced machine learning systems today. Perhaps most importantly, deep learning has vastly improved our ability to understand, analyze image, sound, video, everything. And but for the capstone project, and this will work with number data, numerical data, or categorical data.
Okay.
And this has been made possible by major advance in machine learning research, as well as vast increase in both available data and massive computing power. On the last page, I gave some glossary. You might write down the URL, and then you can do a little research when you want to look at it, glossary.org. So it'll tell you what's algorithm when you click it, if you get chance when you get home, you want to look at data science glossary, right? Okay. So now this is the part of my presentation today. And if you want to look at the course material, if you have question, let me go through that. So I gave the description of the course, and since you are computer sciences, we don't need to probably look at probability. So it's, anybody who has math background can do it. Humanities students, I have 7 of them in my MBA class.
Okay.
They have math. So as long as they understand vector and math, it's easy. It's not like computer science.
Okay.
Because you have the tools. R and SAS are tools to do the thing. So we'll talk about that, and that's why I said R, SAS, and maybe Python I'll introduce, okay?
Okay.
So the primary goal of this course was, I'm putting in standard of a university course, in the way I put it, understanding the theory behind machine learning, which I'll go over all those, supervised, unsupervised learning, how we can look at data mining, exploratory data analysis. Because better the data, better is the quality of the algorithm.
Right.
Then development of skills for applying machine learning technique in big data environment, understanding the design, integration, and use of optimization methodology algorithm statistics to solve machine learning. Development of ability to work on machine learning projects and create solutions using machine learning analytics. Okay. Data analysis and visualization, we can do a ggplot in R or Tableau. I have to download that because I'm not sure if this company has that here. I'm not sure what software I have to ask the gentleman. So EDA is exploratory data analysis and data mining. Then we collect data cleansing and all that, right? So machine learning we'll talk about maybe in the second week. First week will be next week. Supervised learning, unsupervised, reinforcement, testing, evaluating, and validating a machine. Because if you have a sample, you want to divide into two parts: training, where you develop the model, then you test it, and then you have to do cross-validation. Within the sample, we break into 20% and run the algorithm again and again to see if we come with the same signs and same, estimate in that. And logistic regression is traditionally the best machine learning tool. You predict either there will be shooting or not, either there will be a disaster or not, and what are the factors. And that's when you put in the machine, they know how to. It's good in police tracking. And so then this some on the second page I said about linear regression, polynomial, logistic, all the ones that will, and I'll give you some primer on statistical, like a hand note that you can carry, and it's easy to know which one to use when. I will prepare that, okay? Then overview of deep learning, we talked about where it's, they talk about images, videos, how they can look at those. And those algorithms, natural language processing is for text analytics, speech recognition by looking at speech, how they do that.